Right, so again, if you look at it, I'm still looking at the area below the x-axis. Like I told you, if you're finding the area below the x-axis, the area is always going to be negative. So to counteract that negative, we simply say the area is simply given by the modulus. So the integral of the function that you have been given with respect to x, then you can put up your your limits where a and b are representing the limits, or like I said, you can also say negative of the integral of the function with respect to x, where your a and your b are representing the upper limit. Whichever you choose to use, that is very much okay. In this case, my lower limit is a 2, my upper limit is my lower limit is a 1 and my upper limit is a 2. So I'm going to say the area will be given by, so the integral of y with respect to x. And what are your limits? It's 1 and 2. So if I notice there, what is y? Y is represented by x squared minus 3x plus 2, with respect to dx in this case. So we can now integrate that. You add plus 1, so it will be x raised to the power 3 over 3 minus, when you add plus 1 to the exponent, it will be 3x squared over 2. If you have a number, you just add a letter there. So you can attach your upper and your lower limit, which is a 2 and a 1 there. So now we can actually try to replace the upper limit into this expression. So 2 raised to the power 3 over 3 minus 3 multiplied by 2 raised to the power 2 over 2 plus 2 times 2. This is what we are having there. Then minus us replacing the lower limit, which is 1. So it will be 1 to the power 3 over 3 minus 3, 1 raised to the power 2 over 2 plus 2 multiplied by 1. So that is what we have. So the area there, 2 raised to the power 3, that is 8. So that will give us 8 over 3 minus, that will be 2 raised to the power 2, that is a 4. 4 times 3, that is 12. 12 divided by 2 give you a 6, plus a 4 there, minus 1 raised to the power 3 will give you 1 over 3. So 1 raised to the power 3 is a 1 over 3. That will give you 1 raised to the power 2 is 1 times 3. So you're going to have minus 3 over minus a 3 over 2 there. So 3 over 2, then that is going to be plus 2, all right? So we can try to work out that. If you use your calculator, that is 8 over 3, minus 6, plus 4. So that is going to give me a 2 over 3. So that will give you a 2 over 3 minus. You can also try to work out the other one. That is 1 over 3 minus, in this case, 3 over, 2 plus 2 there. So it will give you 5 over 6. So when you work out, this, you sub 2 over 3 minus 5 over 6. That is going to give you a negative 1 over 6. But like I told you, the numerical value, you can simply the modulus of negative 1 over 6. Modulus means if you have a negative, it will disappear, and therefore it will give me 1 over 6, and this is going to be square unit. So that is the area below. So this is the way you can still go about it. So it's not complicated, it is just very simple. So remember, as long as the area is simply going to be below the x-axis, it is going to be negative. So let's say that you do have, in this case, maybe a graph that looks something like this, and they tell you, probably they have given you let me say limits. You have got a, b, and maybe somewhere there c. This is the shaded region that you have. Remember, that is the x, that is the y, and let me use a different marker just to shade this one here, that is actually below. So this one that is actually above the x-axis, that one is positive, and this one that is below, starting from b to c, that is going to be negative. So if you want to to find the total area, you just need to add this area plus that area. But remember how to find the area below. You put up a a negative. So that is the way you can actually, get to do it. Now something, similar also applies to the y-axis. When the area of a region on the left of the y-axis is being found, if you are going to find that it is also going to give you a negative. I'm going to demonstrate in my next video. Thank you so much for watching.